Good afternoon, everybody, and welcome to Agrifood Conversations brought to you by iSelect Fund, the Van Trump Report, and Yield Lab Institute. My name is Tom Bunn, an associate on the iSelect Ventures team. As many of you know, Agrifood Conversations is all about driving innovation in agriculture. We highlight a theme, including emerging topics such as soil health, plant genetics, vertical farming, and aquaculture. I'll just go ahead and ask somebody to go ahead and mute in the background. We're hearing some typing. And today we are joined by Dan Spracklin, the CEO and founder of SoMax BioEnergy. SoMax BioEnergy uses organic waste as a resource for sustainable development and resilient waste management in agriculture, manufacturing, and sanitation. The company diverts agricultural, food, septic, green, and other organic waste from landfills and wastewater treatment plants, and instead uses it as the feedstock for value-added bioproducts, currently including renewable energy, clean water, and fertilizers. Each of you knows companies are more likely to succeed with the right network of customers, talent, investors, and advisors. We've invited you to this call because you are some of the smartest, most talented people in SoMax BioEnergy's market. You are potential customers for their products and services. You've built and sold a company in the agri-food industry, or you are a sophisticated business person or agricultural or food professional who understands the agri-food market and the challenges it faces. Before we get started, we have a quick poll question to get a better idea of who we have on the call today. Please take a few seconds to answer. Additionally, we have a few process comments before we get started. We are not soliciting investment in any way whatsoever. This presentation is to provide information about SoMax BioEnergy's products and services to help them find customers, mentors, or other strategic relationships that can help them grow their business. Secondly, you are all on mute. However, you can use the chat window to ask a question. After the formal part of the presentation, we will answer as many questions as time allows. Additionally, in addition to chat, you can also raise your hand and I can unmute you and you can ask Dan a question directly, whatever you prefer. Finally, this presentation is being recorded and will be available for replay in about the next 24 hours. So without further delay, I'm pleased to introduce Dan Spracklin, the CEO and founder of SoMax BioEnergy. Take it away, Dan.
Thank you, Tom, and thank you everyone for joining us today. My presentation here is on what we call our elemental recycling platform, and it's bringing sustainable circular solutions to the U.S. food system. So I'd like to start off with who we are. SoMax has developed the elemental recycling platform. SoMax is a spin-out of a research and development arrangement between Gray Brothers Septic Services, my other company, and Villanova University, their School of Sustainable Engineering, which is a graduate-level engineering degree, and it takes engineers from all different disciplines and focuses them on sustainability issues facing society. So out of our research, we've actually developed the elemental recycling platform. What this platform does, it's able to take in organic material. It can be anything from sewage sludge to food waste to spent grains. And what we do is we separate all that waste out into its constituent components. So we turn in that material into carbon, hydrogen, oxygen, phosphorus, nitrogen, and then it's micronutrients as well. What this allows us to do is take what's typically a linear flow, a take-make-waste model, and turn that into a circular model that allows for circular flows of materials. Our focus is on creating solutions directly that are impacted in the food, water, energy nexus, and so that's really our play area. Again, this is a spin-out of research and development with Villanova University. We've done 5 years of R&D. We've published 6 master theses, and some of our milestones, we've just been awarded the design build contract for a wastewater treatment plant in the U.S. We're also developing a closed-loop food production system with a Fortune 50 company here in the Philadelphia area, and we are also engaging in the dairy and poultry market in Lancaster, Pennsylvania. And recently we were selected as a finalist of the Yield Lab Institute's Manure Innovation Challenge. The team is myself, Dan Spracklin. I have 15 years of process design and improvement in corporate America. I have 8 years of being an entrepreneur and CEO of a waste hauling business. We have expertise in logistics and hauling waste materials. Jeremy Taylor is our Chief Sustainability Officer. He is actually a graduate of the program at Villanova. He did his master's on the HTC process and is an expert on HTC and is also a process engineer. Prior to getting his master's degree, Jeremy worked for a couple of years for ConocoPhillips in their labs. And then we're backed up on the technical side, and we're led by Dr. Ross Lee, who is a PhD in organic chemistry. He also spent 36 years at DuPont Chemicals, developing, and he led the R&D on materials and design. In addition, we have Dr. Satrio, who is a PhD in chemical engineering and a world-class expert on biomass conversion. So I'd like to talk to you a bit about the problem that we're focused on. And the problem that we're focused on is the U.S. food system. So I'm going to start with a slide. This comes directly from the Ellen MacArthur Foundation. And the issue with food in the U.S. and globally is that we have a very linear model. In here you'll see that there are a lot of inputs into agriculture. And globally we're producing 7.1 billion tons of food for consumption. Out of that, only 4.3 is available for human consumption. Further on with that, you have 2.9 billion tons that's destined for cities. And then what you end up with on the right side of that is you have 2.8 billion tons of organic waste in cities, of which less than 2% of the nutrients are recycled. So we're taking these valuable nutrients from the heartland or from other areas in the agriculture, we're consuming them in cities, and then we're just depositing those nutrients into rivers and then ultimately into the ocean. So what we're focused on doing is cycling that back and taking the end point of the food supply chain and bringing it back to the beginning of the food supply chain in agriculture. So this system is very wasteful and harmful to human health. So the fact from the Ellen MacArthur Foundation is for every $1 spent on food, $2 in economic and environmental costs is incurred. This results in $5.7 trillion in negative societal costs annually on a global level. The other problem that we're facing is a looming landfill crisis. This is particularly acute here in the Northeast, where as of 2021, we'll have 8 years of remaining capacity in landfills. We also have the largest population density in the U.S. Between the I-95 corridor of Boston to Washington, D.C. is approximately a third of the population. So it's very concentrated, and we're going to run out of landfill space within a decade. So what happens is we'll start shipping our waste to the Southeast and then the Midwest and eventually to the Pacific. But you'll notice in here, even in the Midwest, you're predicted to have 11 years of remaining capacity. This chart was actually produced by SWEEP, which is the equivalent to LLD certification for the sanitation industry, so for waste. And then you'll see the quote at the bottom here is from a waste industry that we have to find an alternative that works, is scalable, it's not subsidized, and we have to do this in the next 10 years. So the only way that we can handle currently organic waste are really 4 ways. We can landfill it, land apply it, compost it, digest it anaerobically, and then I'm here to introduce you to a new technology today called hydrothermal carbonization. So as you can see with this chart, there's carbon efficiency is a metric that we like to use. What that means is the amount of carbon in the feedstock material and the amount of carbon that's in the end product. When you're land applying or you're landfilling organic waste, there's really zero carbon efficiency. All of that will valorize into carbon dioxide and methane. In composting, it's a little bit better. You've got 10%. Anaerobic digestion is around 50%, but hydrothermal carbonization, or HTC, is 90%. You'll see also the process duration that goes from anywhere from months to years to HTC can process organic waste depending on what it is in anywhere from 30 minutes to 4 hours. So there's big advantages here. Also, we're about 80% of the CapEx costs of an anaerobic digestion plant, and we're about a quarter of the footprint. So to recap, basically we have all of this waste, we're running out of places to put it, and we've got to do something about it. So with that, I'd like to introduce you to the Elemental Recycling Platform, which is a suite of technologies that allows us to convert those organic wastes into their elemental components. At the heart of our process is hydrothermal carbonization. That allows us to take any waste, to carbonize it, and then we're able to, at that point, separate it from its liquid environment into a solid and liquid process streams. So I'll go through this real quickly. We have the feedstock collection and delivery going into the hydrothermal carbonization system. It carbonizes in the reactor. It separates out. The hydrochar is our solid product. So hydrochar, we'll get into that a little bit later. And then we have a liquid nutrient process. And then we have ancillary technologies that we have partnerships that allow us to do other things with it, depending on what the customer wants. Things like phosphorus recovery. We can create renewable heat and electricity. We can create nutrient concentrates and ammonium sulfate as a organic nitrogen-based fertilizer. So what is hydrothermal carbonization? It's very easy. I'll break it down to you. It's the name. Hydro meaning wet, thermal meaning applying heat. Basically, we're just applying heat and pressure to this organic waste material to convert it. The 5 dots that you'll see at the top, that's all the chemical reactions that are occurring in this process. You'll see at the process conditions on the left, we're operating at temperatures that you bake a frozen pizza at or that you bake a cookie at. We're not talking high pressure where we're talking thousands of degrees like you get with some other methods like pyrolysis or gasification. Our pressure is 290 psi. And then again, depending on the feedstock material, it's anywhere from 30 minutes. So for things like sewage sludge, hog manure, you're around 30 to 45 minutes. Things that are more lignin-based, so hardwoods or forestry residues, is around 4 hours. The pictures down below, you'll see our 2nd generation of reactor and then our new 3rd generation reactor. So these reactors are built on the backbone of a shipping container. So they are actually the standard shipping container size. Each of these reactors will process anywhere from 10,000 to 15,000 tons of wet material per year. So they're modular as well and scalable. So if you can go to, let's say you had 150,000 tons, you just put 10 of these reactors in. We like this because it allows us to build up and build down. Easiest way to think about it is like in the IT world where if you need an additional storage, you just add another server. You don't rebuild an entire bigger server. So what is hydrochar? Hydrochar is a solid fuel. Easiest way to think about it is to think about coal. If the term wasn't ruined by politicians, we would call this clean coal. This hydrothermal carbonization process actually mimics the natural coal occurrence. But instead of hundreds of millions of years for coal formation, we do it in a number of hours. But we get very good energy densities. So this chart's showing our comparison of hydrochar compared to more of the standard coals that you see in the energy production world. You'll see that the blue is our heating value or our megajoules per kilogram, our energy density, and the orange and the green are emission factors. So one of the things you'll notice here is, well, why don't you have any emissions? We do have emissions, but our emissions are biogenic in nature. They're naturally occurring. So the easiest way to think about it is a forest. In the spring, when the leaves are growing, it's soaking up a tremendous amount of carbon dioxide. When those leaves fall to the ground in autumn and they disintegrate into the soil, they're releasing all that carbon dioxide back into the atmosphere. So we're playing with today's carbon rather than fossil fuels that has that carbon stored for millions of years. We're in today's carbon cycle and we're just recycling that carbon. Think of it as respiration, breathing in and out. We're able to do that, but also produce the energy and the power associated with it. So for us, energy is really the low-hanging fruit. It's our minimum viable product. We're ready. This hydrochar can be easily burned at any existing coal-fired power plant in the U.S. It can also be used to set up and gasified on-site to create distributed, localized power and heat generation. Beyond that, we're actually working on a lot of different applications for the hydrochar product. We just received a grant from the state of Pennsylvania to study the hydrochars from food waste and from sewage sludge to be upgraded into activated carbon for advanced water filtration. There's also certain materials that have benefits. So, for example, marijuana or hemp, the bast or the leftover of processing and those materials in the dust, we can take into hydrothermal carbonize those, and we actually will produce a single atom layer thick sheet called the carbon nanosheet. That carbon nanosheet you can stack together in a solution and create a supercapacitor. So now you've created energy storage devices. This hydrochar can also be used as a soil amendment, although there's some studies are saying diametrically opposite things. Some are saying it's very good for the soil. Some are saying it's not so good for the soil. Beyond that, you can actually put this into concrete. It actually makes the concrete 4 times stronger and 30% more waterproof because the hydrochar itself has a hydrophobic shell on it, meaning that it repels water. That's key because in the process conditions and operations, we take this wet material, we process it, and now we've increased the dewaterability, and the cost for dewatering we've lowered by roughly 50%. So anything you do beyond carbon neutral energy production is a carbon sink. This is lowering greenhouse gas emissions and putting it into the ground and sequestering it. What you can actually achieve here is carbon sequestration, utilization, and storage, which is a mouthful, but it's really the holy grail of bioenergy. This is a solution that can be used to store mass quantities of carbon dioxide and carbon into the soils or into building materials. So with that, I'll go into a couple of our technology partners. So we have partnered with a German company called Silcon. They have this piece of equipment that is actually for manure collection. We can take this on site to a farm and go suck out a manure pit, whether it be hog manure or cow manure, bring out the solids. This uses cavitation to create a solid that's now balable. We put that into a baler, we make bales, and then those bales can be shipped to a centralized location for processing off-site. So that's a situation where you can have lots of area farms combining into one centralized production facility to gain economies of scale. Our gasification unit is by a company, AHT, out of the Netherlands. This has been used over 40 years. It's one of the most efficient gasifiers. A lot of questions we get is why do we gasify this or recommend it? And that's because of the energy efficiencies. Here you'll see it's 88% efficient between thermal and electricity transfer, as well as its lower emissions. So this gasification process actually cleans up a lot of pollutants. The way that it's combusted lowers the SOx and NOx emissions. So beyond just carbon dioxide and CO2 emissions, we're actually lowering other emissions that are actually more harmful to the environment. And then we have vacuum distillation, and this is where we're able to take our processed water, we put it through an evaporator. That evaporator now concentrates down all the minerals and then creates essentially a distilled water. From that evaporation, we can add sulfuric acid into there to generate ammonium sulfate. Ammonium sulfate, again, is a bio-based nitrogen fertilizer that can be used in replacement of fossil fuel-derived nitrogen fertilizers. And then the concentrate can actually be used for nutrients for your soil. So this is where your micronutrients are, your calcium and things like that. This has a very low temperature, and then we actually can run this through the waste heat of the gasifier, that there's no outside energy component. Our goal in this is to build standalone operations that need no outside energy input. So these are things that are independent from the grid, and that allows us to put them virtually anywhere. So I want to go real quickly over 3 projects that we have in development. These are going to follow a suburban, urban, and a rural model, and gives you the idea of flavor of what can be done. Since we have a platform that's very flexible to meet different demands and can actually have a lot of innovative data solutions. So this is actually, we've been awarded the design build contract at Phoenixville. This will be the first installation of hydrothermal carbonization technology in the United States at industrial scale. There are a half dozen companies worldwide that have hydrothermal carbonization plants. They're primarily in Europe and Asia because of the limited land constraints and more of the environmental factors that they faced. But this, to our knowledge, is the first one in the U.S. So a little bit about this project. You'll see in the picture, here's the layout of the treatment plant. This is a 3 million gallon per day treatment plant that is actually land applying their biosolids as Class B fertilizer. They do pay a company to actually take this and apply this at farmland or agricultural land in Pennsylvania, Maryland, and in Virginia. There is some legislation pending both in Maryland and in Virginia to outlaw the application of biosolids, and there's also a lot of pressure here in Pennsylvania to outlaw land application of biosolids. One of the primary drivers of this is PFAS. PFAS is a forever chemical. It's in a lot of flame retardants. It's been shown to accumulate in the human body, and it's a toxic material. There has been a dairy in Maine that has just shut down because they were land applying biosolids on their land. Those biosolids, the PFAS got into the feed got into the cows, the PFAS got into the milk. They could no longer sell their milk, so they had to close down the dairy farm. So this is a lot of emphasis behind why we're seeing a lot of anti-land application legislation. The other thing is if you can't land apply it, you have to landfill this biosolids. And we're predicting in the next 10 years that the disposal costs will double from the tip fee right now in Chester County is $65 a ton. That will go up to $150 a ton in 10 years and keep going up and up from there. So this is a long-term solution for the borough of Phoenixville to handle a waste product that they will always have. The nice thing that we'll be able to do here is we'll be able to take their biosolids, process them into hydrochar, and then gasify them. And when we gasify them, we're going to create enough electricity to not only run this treatment plant, we'll run the water treatment plant, all the stoplights, all the stop signs, and all municipal buildings within the borough. This allows the borough to go to 100% renewable energy and significantly reduce their carbon footprint. So this is just a quick overview of what the process is at the borough. We're processing 51,000 gallons a day. And then we're actually here recycling that processed water back to the treatment plant. Our recycling rate is 3.3 million gallons a year, and that represents less than 1% of the water that's being treated at the treatment plant. So that water just goes back to the headworks and gets treated normally. We're not doing the vacuum distillation here. This process will end up with 1,700 tons of hydrochar every year. And again, that's where we get our energy. The second phase of this project is to put in a second reactor to actually take food waste from the local restaurants and breweries and grocery stores from this community and process them. At that point, we'll be able to power an additional 500 homes within the community. This is a picture of the award. We were just granted a $400,000 grant by the Chester County Commissioners. They want to see this sustainability play in Chester County. For those of you who don't know, Phoenixville is a suburb, northwest suburb of Philadelphia. It's about 22 miles northwest of downtown Philadelphia. So this is a nice picture with all the politicians. I am on the left. You'll see me holding up the sign, and then you'll see Jeremy in the mix. So what does this do from an economic impact? The total CapEx for this project is going to be about roughly $5.5 million. They have operational expenses of about $250,000 a year, but this has an annual savings of $1.6 million for them. It results in a 4-year payback. But I want to point out here, the lower right-hand corner, you'll see there's a 20-year impact to the borough of a savings of $33 million for this process. So that's a good return on investment. And you're dealing with something that, the municipalities can't ever say they're going to stop treating waste. It's something that's going to be here as long as there is a municipality. So now we want to move into the urban solution that we have. So we've been working with a Fortune 50 company here, and we have interest from a lot of other companies, and we're starting to engage actually the city of Philadelphia. The big driver behind this is twofold. One is that the city of Philadelphia and a lot of the corporations that are headquartered here have 100% zero waste goals, meaning that they don't want to send anything to landfill anymore. Those have horizons far in the future, about 20 years. But this is a way we can do that. The other problem that we have here in the Northeast is with our produce. Any lettuce that you're going to buy here in the Northeast is traveling at least 3,000 miles, and it's coming from either Arizona or Southern California. So that's 6,000 miles round trip for that salad that you had for lunch, or that you'll have with your dinner. So the process here is we're taking food waste from these corporations to help them achieve their zero waste goals, to help them achieve their lower carbon emission goals. We run it through the hydrothermal carbonization process. We do vacuum distillation. Now we're creating fertilizers and distilled water. That distilled water goes into a vertical farm. The fertilizer, the ammonium sulfate, is then looking to be sold back into the rural community, into the ag community, to recycle those nutrients. All of the heat and electricity are used for the vertical farm to power the grow lights and to provide the necessary cooling associated with the production of this. So here we've developed a completely closed-loop food production system for produce that, we've cut down that transportation network from 6,000 miles round trip to less than 30 miles round trip. So this next one gives you a mass and energy balance, shows you a 10,000 ton input at 25% total suspended solids. This is what we'll end up with is all the numbers you'll see here. But the key thing is that we'll have a net energy production of around 2,200 megawatts of electricity. That 2,200 megawatts of electricity is enough to produce 500,000 heads of lettuce per year. That can go then be sold back to those industries that are sending us their food waste. We're also working with Villanova on this. So again, it's closed loop. You give us your food waste, we process it, we sell you back fresh produce from the energy that was derived from that food waste. So a little bit about the carbon reduction here. This is actually, we did 3 LCAs, life cycle assessments on this process, and our results show a nearly 7 million kilogram reduction in CO2 emissions. That's the equivalent of taking 1,600 cars off the road, and it's a 140% decrease in CO2 footprint from the status quo of sending that food waste to a landfill. So in addition to that, we looked at energy sources. So this is looking at a chart looking at the base case, which is looking at the conventional farming process and a closed loop system. At the top, we've had to bring conventional farming up to 100% just so you can see that our impacts. So the bottom portion here is the actuals, but you'll see if you look at global warming or ozone depletion or smog, there's no impact. We've had to raise it up to 100 to see those minimal impacts that we have. The other thing is looking at the transportation of that. Again, this is traveling 6,000 miles from Southern California to Philadelphia, New York, Boston, and based on that, our reduction in transportation is dramatic. So beyond that, I want to get into the last one, and the last one is our newest one. This is very new. We've only started discussions with these companies in the last couple of weeks. So Creeder Farms is located in Lancaster, Pennsylvania. They have a combination of a dairy farm and chicken farm. They have 4,000 dairy cows. They're producing 10 million gallons of milk annually, with 4 million chicken layers, producing 1.2 billion eggs. And then what they're actually looking at doing is in the opposing property is building a feed mill. And we're talking to them about putting our unit on there. And what the nice thing will be here is that we'll be able to take the waste from these animals, process them into heat, electricity, and clean water and nutrients. Those nutrients will go back onto the farm fields. The water will actually go back to consumption for the cows. And the heat and electricity is actually used to run portions of the dairy farm from an electrical perspective. And the heat is being used to dry the chicken feed. So all this is done through a tunnel between the two adjacent properties. This allows us to eliminate roughly 500,000 vehicle miles. We'll also be able to reduce nutrient loads to the environment. So a little bit about Lancaster, Pennsylvania. They have sort of a nutrient abundance. They have too much phosphorus in the soil and too much nitrogen. So what we're able to do is actually take the phosphorus here from a place like Lancaster, and we'll be able to sell that into another market that needs phosphorus, that doesn't have the issues with phosphorus that Lancaster and the eastern shores of Maryland, anywhere there was a big concentration of poultry production, you're going to have phosphorus issues from the land application of chicken litter and its high volume of phosphorus on those soils. So these are very rough cut numbers. Again, we've only been dealing with this recently, but the total will be able to reduce 2 million pounds of nutrients to the soils here, and that will be able to be transported to another market. And will roughly 28,000 megawatt hours of electricity and roughly 15,000 megawatt hours of thermal energy. So what this does and why Creeder Farms is very interested is we've had some discussions with a local grocery chain here called Wegmans. And what they're doing is they're looking for a new brand segment. So you saw, maybe a decade or so ago, the leap to organic, and the price difference between organic eggs, free range organic eggs, and traditional your traditional eggs is dramatic. So they're looking for a midpoint between those. And what they focused on, and you'll see this from a lot of retailers, you'll see this from the Walmarts and from the Krogers and all the grocery stores, are trying to lower their carbon footprint. And by reducing these amounts of carbon, this amount of fossil fuel use, we're able to satisfy those requirements and then actually sell this product at a higher premium. So Wegmans is talking about 60 cents a dozen eggs higher than the traditional egg. That delta in price actually allows for the farm to pay for all of its infrastructure. And over a 20-year period, will make, a tremendous amount of savings and a tremendous amount of more income based on doing what they're doing today. So our value proposition is really about driving your growth and enhancing your brand, increasing profits, and also reducing risks. So we're future-proofing anti-land application legislations. We're future-proofing greenhouse gas emissions reductions. One thing you'll notice about us is, unlike some of the other players in this organic waste space, anaerobic digestion and creating biogas, we don't rely on subsidies. There are no federal subsidies for this. We're not going after those. These stand alone on their own and make a profit. The other thing that we do is we have this, we can calculate all the savings, and that you don't necessarily have to use that energy on site. You could sell that energy into the market, into a coal-fired power plant. So we're creating additional revenues to help increase the stability of the farm. So with that, just a real quick summary. It's a robust conversion technology. We don't depend on biological processes, meaning that this will work anywhere. We don't have to manage pH. We don't have to manage temperature. We don't have to worry about microbials. We don't have to worry about bugs. We don't have to worry about a hot load coming in and killing our bugs and waiting a month to rebuild that. We can do this with any material. It's a wide feedstock of material. We are, according to the World Energy Foundation, hydrothermal carbonization is the most efficient biomass conversion technology. Again, up to 90% of the carbon is converted. We reduce up to 65% of the carbon footprint compared to other technologies like anaerobic digestion. So again, we have a very small footprint. Our base reactor and our base case is roughly 4,000 square feet. That's 3 shipping containers put together. But again, you can build these up. The majority of our footprint is actually in ancillary equipment. It's in things like storage hoppers, pumps, dewatering equipment. We can also do tailored nutrient recovery. So we can take out phosphorus and give you back the nitrogen in the water if you want, or we can go the full scale, give you back distilled water, and have these nutrients available for you. The other big thing for me is that we don't have any stranded assets. So when we talk to a lot of farmers, they have been approached by anaerobic digesters in the past, but they don't have a pipeline near them to get to. We don't need pipelines. this solid fuel can be shipped the same way you ship coal. So it can be shipped, on train, on a barge, on a ship, on a truck, and it can be shipped anywhere in the world. So you can actually play the market and look for high feed-in tariffs or high tariffs for renewable energy. Some of those markets include the UK, Japan, or any island nation that has a higher economic principle or an economic price on energy. One of the initial discussions we had with Phoenixville was not using that energy and actually selling it to the market and selling it to the island of Jamaica, where they're paying 33 cents a kilowatt for electricity. So there are a lot of factors that you can play with this. You're not stuck with biogas that you've got nothing to put it in. And in addition, we also have the potential for carbon sequestration and positive environmental returns. So with that, I think we'll turn it over to questions. My contact information, if you would like to get a hold of me separately, is right here on your screen. And I thank you very much for your time and attention.
Great. Thank you very much, Dan. Really appreciate it. Very fascinating stuff you're working on. As a reminder to those in attendance, to ask a question, go to the question window on the right side of your screen, or put your hand up and I can unmute you. It looks like Kim Wagner has a question. They ask, can the resulting fertilizer be certified for application on organic fields?
I can't definitively answer that yet because we haven't gone through all the testing, but from a conceptual level, it's biogenic in nature, it's organic in nature, it should be able to qualify as organic. When you get into some of that, there are some things that don't necessarily make sense. For example, I'll give you an example. From our lettuce that we're growing in a vertical farm, even though it uses all natural organic nutrients and fertilizers, it can't be qualified as organic produce because it's not grown in soil. Because it's grown hydroponically, it can't be certified as organic. So in that industry, we're going with the option of beyond organic. So that's, unfortunately, I can't answer that question definitively now. From a common sense perspective, yes, absolutely, it should be certified organic, but the technicalities and the policy framework is what can sometimes get in the way.
Got it. Dan, which application are you most excited about?
I'm excited about all of them. I think what we've shown you today is there's a lot of different applications. My focus, I think the biggest bang for the buck is the focus on food waste. To give you an example, in the Philadelphia metro area, there's 1.7 million tons of food waste every year. That's just a tremendous waste of resources that can go back into this. If you look at this I-95 corridor between Boston and DC, operating at 100,000 tons of food waste, we can build over 150 of these to capture the amount of these plants to capture the amount of food waste. It's just a truly staggering number. The one that really, I think, excites me a lot, though, is the municipal model, because there you're taking something that we're always going to have, we're always going to deal with, and you can do something positive with it. Run the entire municipality on 100% renewable energy. Stuff that they were throwing away can now be a fuel source for them. And this applies in any municipality. We're not intermittent. We run 24/7, 365. So we're not relying on, solar panels or wind. We don't have to store this stuff in batteries. I think that's a truly win-win situation as well. And to be honest, I think the agricultural community intrigues me quite a bit. Although we're not as developed in that space yet, that's one of the genesis for us applying for the Manure Innovation Challenge, was to understand the needs of the ag sector. I'm a Midwest boy, born and raised in Des Moines, Iowa. Moved out to Philadelphia about 15 years ago, but I never grew up on a farm, so I didn't have that exposure to the agricultural. But I'd like to get back to the heartland and get back to those communities. I really do miss being the Midwest attitude and the kindness of strangers in the community.
There you go. We pride ourselves on that. What's the biggest thing keeping you up at night these days? Business related.
Business related is really the biggest thing keeping me up is, be honest, climate change. and that how can we scale this quickly enough to have the impact that we need to have? How do we go from this first unit? I can tell you we have tremendous amount of interest from a lot of big players in the space. We have a tremendous amount of interest from some waste companies that run landfills. And they have told me that, without even trying, they're getting 6% of the biosolids ending up at landfills. And organic waste is the single largest component in municipal solid waste. So that's the single largest component we're throwing into our landfills that we're filling up that should be taken out of there. And it's how do we go from this small startup company to, a nationwide company? How do we scale this quickly while maintaining, our culture, our mission, our values? And that to me is a big challenge on how do you go from a team of 5 people to a team of 5,000 people and not lose sight of things and start to become more of a company that cuts corners and is solely about profit. We're not about profit here. We are a triple line bottom company. We will measure our successes based on our impacts to environment as well as our economic success.
Great. Any other questions from the attendees? Okay, well, Dan, I want to thank you again for your time. To everyone in attendance, thank you for joining us. As a reminder, we host these calls every Thursday at 3 p.m. Central. So please share and tell your friends, and hopefully we will see you next week at 3 p.m. Central. Again, thank you very much for your time. And as a reminder, a replay will be available in 24 hours. And tell your friends to register by going to agrifoodconversations.com. And they can register and then get all the replays of this webinar and past webinars as well. So thanks again, everybody, and have a great afternoon.